So in this video, let's talk a bit about Fischer esterification. So the idea is that we're gonna take a carboxylic acid and we take an alcohol. So here's our alcohol. Here's our carboxylic acid. So we take a carboxylic acid and we take an alcohol. We drive this reaction forward in acid and heat. And here's what we get. We get the ester plus some water back. Okay, so that's a general procedure for Fischer esterification. Now, these are typically done in acid and not base. Okay, so let's go through the mechanism. Okay, so in the first step, you have your carboxylic acid. Okay, and remember, if we throw this in heat, and we throw any sort of carbonyl in heat, the first thing it's going to do is get protonation. So this is going to come and attack a hydrogen. Okay, and we reform water in solution. So here's our OH. And now we have an oxygen that has a positive charge. Okay. Now in the second step, our nucleophile in this case, which is ethanol, the lone pairs on the oxygen will actually come in now and attack the carbon contained in attack the carbonyl carbon and move these bonds in a pair of lone pair on the oxygen. Okay, and so we come to a structure that looks something like this. We have our OH. This is now bonded to an alcohol, an oxygen that has a hydrogen plus this group here, and I still have my alcohol which was formed. Okay, now remember, oxygen with 3 bonds, automatic plus charge. Okay, now we formed water in solution, and so water is going to come in and reform acid by taking this proton off and putting the molecule in a neutral state. Okay, and so we come to this OH here. We know that that's bonded to that, and we still have our OH. Now, what would happen in the next step? Well, the oxygen adjacent to the ether group, the oxygen that's adjacent to the ether group will actually get protonation, and so water. So we just formed acid in solution. Okay, so it actually take one of those protons off and reform water in solution. Okay, and so that being said, we've gained protonation. So we have an OH that's now bonded to an oxygen that has 2 hydrogens, so it's a plus charge because it has 3 bonds, and we still have this O group here. Now, what we did was we just form a great leaving group, and so this bond here is going to come in and form a double bond and expel water as a leaving group. And if you're looking at this, now we have something that looks like this. We have a double bonded that's now bonded to an oxygen that has this group here. Okay, so we form this plus water, and we still have acid. Okay, and again, you could just remove the excess water, which distillation, all that good stuff, and drive the reaction forward. So this is how we do Fischer esterification. So it's a general procedure of taking a carboxylic acid. So maybe if I take a benzoic acid and I add maybe if I add methanol. So if I add methanol in acid, okay, well, again, we know this is Fischer esterification, and so I'm gonna have my carbonyl that's now bonded to an oxygen that now has my CH3 group. Okay, so you can see we're creating the esters. Okay, similarly, if I take this compound, this acid, and I add, I don't know, let's see, if I add ethanol in heat, acid in heated conditions, I'm simply going to get the ester. So I keep my oxygen. This oxygen is now bonded to a carbon that has that. Okay, and this is my product. There's my ester. So there's my ester. So Fischer esterification is not that difficult. Again, the general idea is that we take a carboxylic acid and we add an alcohol, and we get the ester. And again, a quick way of predicting the products is rewrite your carboxylic acid as is, except leave out your hydrogen and just bond it to whatever the carbon chain is. Okay, so let me go through the procedure of how I got this, how I got the product. Well, I just said to just rewrite the carboxylic acid. I'm gonna leave my hydrogen out because that will actually leave in solution. So there's my carboxylic acid. I just simply bond it to whatever the carbon chain is, because I'm actually going to lose this alcohol in the form of water. Okay, so this is now bonded to a carbon that has this. And again, that's all the product. So a quick way of predicting these products is just to redraw your carboxylic acid, drop the H, and then draw the bond to whatever the carbon chain is.